When you see a headline about pollution, whether it's, sewage in a river or just bad air quality in a city, that data isn't a guess, it's evidence.
Exactly. And that evidence comes from highly specialized environmental laboratories that operate under just astonishingly strict rules.
Today, we are taking a deep dive into the source material that governs these environmental watchdogs. The intense, systematic, and frankly incredibly detailed requirements from organizations like the Central Pollution Control Board. They define what it means to be a competent laboratory.
And our mission here is to really understand the layers of rigor involved.
Right. We're going inside the lab, not just to look at the big, expensive machines, but to examine everything. From the specific anti-corrosion coating on the furniture to the use of actual brass seals on legal evidence, it's a shortcut to understanding why environmental data integrity is so hard-won.
And the why is the most important part. I mean, environmental labs are the cornerstones of any effective pollution control program. They provide both the qualitative and the quantitative data.
So what something is, and how much of it there is.
Precisely. And that data needs exceptionally high accuracy because it often becomes legal evidence in court. It's used to enforce critical laws like the Water, Air, and Environment Protection Acts.
So if the data is flawed?
If the data is flawed, if the sampling was wrong or a machine wasn't calibrated, the entire legal case for environmental protection can just collapse.
So the stakes are literally judicial. Let's unpack that core legal foundation first. The guidelines start with a pretty straightforward definition of the enemy. Pollution is an undesirable change in physical, chemical, or biological characteristics of our environment.
Right, and to manage this, the law doesn't just suggest testing. It legally requires environmental labs to be established or formally recognized.
It's mandatory then.
It's absolutely mandatory. Think of it like certifying the referee before the game even starts. Under the Water Act of 1974, for example, specific sections mandate these labs and the appointment of a government analyst.
And their report is the key.
It is. Critically, the report signed by that analyst is explicitly designated to be used as legal evidence. You are essentially generating a scientific deposition, which is why the quality has to be, well, non-negotiable.
I think most of us assume that data quality just rests on the expensive instruments, but the source material is quick to correct that. It insists quality starts with the infrastructure.
That's so true. People miss this.
Yeah, things like sufficient space, specific design, controlled ventilation, stable temperature, even a dust-free atmosphere. All these seemingly minor factors directly influence the reliability of the data.
It's a holistic quality system.
Yeah.
If the environment of the lab is compromised, the data is compromised. And to ensure that doesn't happen, a recognized lab must have distinct, segregated work areas.
To prevent cross-contamination.
Exactly, to prevent any chance of it.
So what does that segregation, what does it actually look like in practice?
It's highly specific. You need dedicated sections. You can't mix your water analysis, which is broken down into physical, chemical, microbiological, and biological, with your air analysis.
And that's separated too, right?
And that is also separated into ambient, source emission, and vehicular emission testing. Beyond that, you need separate, dedicated rooms for instrumentation, sample receipt, sample storage, and critically, a digestion and extraction room.
Why is that one so critical?
That's where you might prepare samples for things like heavy metals or pesticides. You have to keep that prep work isolated to guarantee data trust.
Digging into that infrastructure, I found some details that just really stuck with me. Take the furniture. We're not talking about something you buy flat packed.
Not at all.
Workbenches have to have acid and alkali resistant tops. Any steel or aluminum frames must be non-corrosive. It's a subtle point, but you can't have the bench itself becoming a source of contamination.
And they treat the power supply with the same rigor. Constant stabilized voltage is essential for sophisticated instruments like an AS, that's an atomic absorption spectrophotometer.
Which measures tiny traces of heavy metals like lead or mercury.
Right, or a GC, a gas chromatograph. These machines rely on perfect electronic signals, so labs must have voltage stabilizers and an uninterruptible power supply, or UPS. The source even requires diesel generator sets for continuous operation.
Because a power flicker could ruin a whole batch of tests.
Especially for things like BOD incubators, where a power failure could destroy a time-sensitive measurement.
I think the biggest surprise for me, and probably for a lot of people, is the water purity standards. Most of us think distilled water is pure, but that's not even close to good enough here.
No. For preparing reagents, the guidelines demand the highest grades. Ultra pure, or nano pure. We're talking conductivity approaching theoretical zero. Specifically 0.1 microsiemens per centimeter.
And just to put that into perspective for you, your tap water is often around 500 microsiemens per centimeter.
So these labs are aiming for 1/5000th of that. If your starting material, the water, is impure to that extreme degree, you've introduced errors before you even touch a sample.
And the rigor just continues with maintenance schedules. The guidelines require these intense logs for everything.
Everything, like cleaning a pH meter electrode daily, or the AAS exhaust system. It has to be checked every day with a smoke test to make sure fumes are venting properly.
Even the HEPA filters in the laminar flow hood, which keep samples sterile, have to be serviced twice a year by an external contractor.
And that maintenance schedule is useless without calibration. Support equipment matters just as much as the primary instruments. Think about the analytical balances.
The scale.
The scales, exactly.
Yeah.
They have to be serviced annually by an approved vendor, but the analyst must check them daily using certified weights. Or refrigerator storing samples, those temperatures are logged daily and kept strictly between 2 and 6 degrees Celsius.
They are just systematically eliminating every single potential source of error.
Everyone.
This moves us seamlessly to the next critical step, sample handling. Once that sample leaves the field and arrives at the lab, it enters a chain of custody system that treats it. Well, it treats it like legal evidence in a criminal trial.
It has to. Every single sample gets a unique ID code, indelibly marked on a durable label. This unequivocally links it back to the precise time and location of collection, prevents any confusion. Traceability is paramount.
The sample acceptance policy, though, that reveals just how time-sensitive this data is. The documentation has to be perfect, but the clock is running fast.
Incredibly fast. Yeah. Consider BOD, biochemical oxygen demand. It's a living process in the water. So the maximum regulatory storage time is only 48 hours, and the recommendation is test within 6.
You can't let the sample just sit around and change.
I can't. And some things are even faster. Volatile parameters like pH and dissolved oxygen, they have to be analyzed immediately. We're talking within 15 minutes.
Wow, that makes perfect sense. The moment you open the container or the temperature changes, the dissolved gases start escaping.
Exactly. And if thermal preservation is required, like keeping a sample at 4 degrees C, the rules say it's only acceptable if it arrives within a tight range, plus or minus 2 degrees of the requirement. A sample that arrives at 10 degrees C is simply rejected. It's compromised.
Okay, so what about when a sample is collected specifically for legal enforcement, what they call a legal sample?
That's when the process becomes a literal ritual of security. These samples must be sealed on site immediately after collection to maintain integrity and prevent any chance of tampering.
And the sealing process is formal, right?
Very formal. The sample is collected in enough quantity to be divided into 2 uniform portions, and both are sealed using sealing wax, thread, and often a unique brass seal that identifies the collector.
And the guidelines are absolute on this.
They are. If a sample arrives at the lab with a broken or damaged seal, it may not be accepted at the sample receiving window, period. The chain of custody is broken, the evidence is tainted.
That brings us to ensuring the data itself is trustworthy, even when the seals are perfect. This is where quality control systems come in.
Right, and it starts with accreditation, things like NABL or the global standard ISO 14025. This is formal recognition that the lab has technical competence. It builds trust.
But the accreditation is only as good as the quality control, the QC systems running every single day.
That is the core strategy for generating reliable data of known precision and accuracy. And it all starts with pure reference materials. Certified reference materials, or CRMs, which are materials of known, verified composition. They're essential for calibrating instruments.
Okay, so to make sure the lab itself isn't introducing bias, they run these intense internal QC checks. Let's start with one called the method blank. What is that exactly?
The method blank is simple, but it's brilliant. The analyst runs the entire analytical process, all reagents, glassware, everything, but instead of a sample, they use only that ultra-pure water.
I see.
If the result shows any contaminant, they know they have contamination coming from their solvents, their glassware, or just the lab environment itself. It catches systemic contamination before it taints a real result.
So once they confirm the lab is clean, they need to check if their method actually works.
Exactly. That's the laboratory fortified blank, or LFB. It's a clean sample, the blank, that they then intentionally spike with a known concentration of the pollutant.
So they add, say, 10 parts per million of a heavy metal?
Precisely. And if their analysis only finds 5 parts per million, they know their method is only 50% efficient. They have to stop and fix the procedure before they touch a real environmental sample.
Now here's where it gets really interesting for me, for inorganic analysis. The post-digestion spike, or PDS. This deals with something called matrix effects. What are those?
Think of the matrix as everything else in the water sample besides the chemical you're looking for.
Okay.
If you're testing for arsenic in clean rainwater, it's easy. But if you're testing for arsenic in, say, salty industrial runoff, the salt can actually suppress or enhance the instrument signal, making the arsenic look higher or lower than it truly is.
Ah, so the other stuff in the water is interfering with the measurement.
That's the matrix effect. The PDS involves spiking the sample after the initial preparation to see if the matrix is interfering. If the recovery is poor, they know the sample itself is skewing the result.
That's fascinating. So they're testing their method, their lab environment, and the sample's own chemistry. How do they track all this quality data?
They use what's called a control chart. This chart uses statistical analysis, the mean and standard deviation from at least 20 standard runs.
And this creates limits.
It creates limits. They define warning limits, which are plus or minus 2 standard deviations. If a daily check drifts to that level, it's a yellow alert. The analyst has to investigate. But if the result hits the rejection limit, plus or minus 3 standard deviations, the whole system shuts down.
The runway is closed.
Precisely. No data leaves that lab until the method is fixed, the equipment is recalibrated, and a new acceptable QC result is logged.
And finally, they participate in external QC checks to ensure comparability between labs.
Yes, the CPCB's Interlaboratory Proficiency Testing Program. They circulate identical samples to different labs to see if Lab A gets the same result as Lab B.
And there are consequences for failing.
Major consequences. Failure to achieve a minimum satisfactory performance, not less than 60% success, can actually threaten a lab's official recognition.
Which brings us to that formal process of getting recognized. The prerequisites are demanding. You need a minimum of 9 full-time skilled workers.
And those guidelines dictate specific educational requirements. At least 3 of those workers must hold a master's degree in science or a bachelor's in engineering or technology. This is not a summer job.
No. And the space requirements are laid out too. A minimum of 100 square meters for a water lab. They also can't just cherry pick the easy tests.
Correct. The lab must qualify for specific mandatory parameter groups. They have to demonstrate competence across a whole range of pollutants.
And the evaluation process itself is this multi-step hurdle laid out as steps I through 12. What makes this 12-step process so robust?
It's the depth of the scrutiny. After preliminary checks, there's a joint inspection by a qualified team. And these inspectors aren't rookies. They have to have a minimum of 10 years of relevant experience.
So it's not a self-declaration of quality. It's a veteran's stamp of approval.
Absolutely. The report goes to an expert committee for final review. If accepted, the lab must formally accept strict terms and conditions before the recognition is finally published in the Government Gazette.
And even after all that, the recognition is temporary.
It's only granted for 5 years. To renew it, the lab must compulsively participate in those CPCB quality control exercises and maintain that satisfactory performance. If they fail the proficiency tests too often, the renewal is denied. There's no grandfathering in.
Wow. We have traveled from the ultra-pure water through the non-corrosive furniture past the statistical vigilance of the control chart, all the way to the brass seals on legal samples. The complexity required just to generate one piece of environmental data that can stand up in a court of law is, it's just astounding.
The whole system is designed to be a firewall against error. It's built to remove both random errors, like a power flicker, and systematic errors, like those matrix effects. The goal is always traceability, legal defensibility, and minimizing bias, so that policy decisions are based on fact.
So what does this all mean for you, the well-informed learner?
This deep dive shows the immense standardized effort required just to measure pollution with any confidence. We now know that achieving this level of data integrity is a fragile, multi-layered, 12-step validation process. If reliable data is such a hard-won, highly regulated achievement, what happens to environmental governance when shortcuts are allowed? Or when political pressure compromises the independence of any one of those steps? The integrity of the environment really begins and ends with the integrity of the lab.
This is the brief on environmental laboratory recognition guidelines in India. So India's Central Pollution Control Board just updated its guidelines, and they're really setting a high bar for environmental labs. See, these rules lay out exactly what a lab needs to do to get officially recognized under the Environment Act, and that recognition is a huge deal. It's what makes their data scientifically reliable, and maybe more importantly, legally defensible in court. First up, to even get in the door, labs need to have two major certifications running at the same time. We're talking about the ISO standard for technical competence and another one for worker health and safety. And it's not just paperwork. Physically, these labs need at least 150 square meters of working space and a minimum of 9 skilled staff. Okay, second, there's a crucial role here, the government analyst. Every recognized lab has to nominate a few of their senior experts for this title. These analysts are the only ones authorized to sign off on the final reports, and you better believe that signature is what gives the report its legal weight, making it actual evidence in a court of law. And finally, getting recognized isn't a permanent pass. Labs are under constant watch. They have to participate in quality control exercises and maintain a score of at least 70%. Plus, they can be hit with unannounced surprise inspections at any time. Fail any of this, and a lab can have its recognition suspended or just revoked, plain and simple. So at the end of the day, these tough regulations are all about making sure the data used to protect India's environment is top quality and legally rock solid.